Now next at slip 6-7, we're dealing with, again, more with combining like terms to generate equivalent expressions. And we're trying to find every one of these here. There's 6 options that could be equivalent to this one. So I think to start out, before I just start jumping into these, I'm going to change this to some different forms. I'm going to distribute here so we can take a look at it in some different ways that we'd see it. So let's distribute. This looks a lot like it's the same thing we did in the last exit slip. We've looked at this one, so let's distribute again. 2 times x is 2x plus 4. Again, I took the 2 times everything inside there, plus the 2 times the x is 2x minus 2 times 1 is 2. All right, so we had that expression there when I distribute. And then we also combined like terms, remember, and we took the 2x plus the 2x to give us 4x's. And then we had plus 4 minus 2, and we got this positive 4 minus 2, which means we still have plus 2. Okay, plus this 4 minus 2 is a positive 2, so we have to add 2 onto there. So there's some different form. The simplest form we found, and then this is after I distributed. So when I look through here at my choices, I've got 2x plus 4 plus 2x minus 2. I see that these are exactly the same. This is the form after I distributed, so yes, this is equivalent to this. I've just distributed, so that one works. This second one, this is identical to this. 2 times the quantity x plus 2 plus 2 times the quantity x minus 1. So that's the easiest one there. They didn't change anything. It is exactly the same. All right, so that one, pretty simple there to see. This one, 4x plus 4 minus 2. And I know I have 4x's. Okay, so I know that part's right. And if I looked at this distributive form here, see it was plus 4 minus 2. So if once I combine those, I could have written 2x plus 2x is 4x, and then I still have a plus 4 minus a 2. And I had already combined that to be a positive 2. But in this case, they hadn't combined the second part yet, so that is exactly the same too. It will all of these will turn into 4x plus 2 if they're equivalent. Okay, so I know this one works as well. So I know those 3 are all the same so far. This one, if I take a look here, 2x, this is 2x minus 2x. That would give me 0 x's. I already know this one's not right. Okay, and a positive 2 minus 2 would give me minus nothing. That is definitely not the same as this. Okay, so that one I'm going to get rid of. This one when I distribute, let's take a look here. I've got 2 times the quantity x minus 1 plus 2 times the quantity of x plus 2. Actually, it's the same as this one, but I flipped. And I know with the commutative property, I could put this one here and this one in the back and just flip these around. It would be the same thing. Or we could just distribute through here and double check. This is 2x minus a 2 when I distribute, plus 2x plus 4 when I distribute here. Again, if I combine like terms, 2x's and 2x's, those are 4x's. Now it's in a little different order here than it was up here when I distributed, but I have minus 2 or a negative 2 plus 4. So negative 2 plus 4. Guys, that's still a positive 2. We haven't dealt with negatives as much this year, but if I have negative 2 and I add 4, I'm in a positive 2. This would result in a positive 2. So again, it's still 4x plus 2 in simplest form. If I have a negative 2 and add 4, I get a positive 2. So I need to add more 2 more to that. So I know this one is correct as well. And then I look at this last one. If I see 2x and combine that to minus 2x, that's 0x again, plus 4. I know that one is definitely not the same as this. So I have 4 that are equivalent here. And when it says explain how you know that the expressions you selected are equivalent, again, that's that whole process. I'm not going to write that right now. But guys, actually we could write this. I distributed and combined like terms. And when I did that, I could see if they were the same or not. Now guys, I could have substituted. We've talked a little bit about that. If I substitute a value in for x and plug it in, if I say x is 5, 5 times 4 is 20 plus 2, the whole thing would equal 22. And I could plug that 2 in everywhere where I have an x and see if this expression equaled 22. If it did, they'd be equivalent. Again, that's another way to do it. I think that way takes a little bit longer in this case. to plug in and actually solve all these if you say x equals 2 and find all the ones that are the same. So we did it with the distributive property and combined like terms.